Okay, this is on page 18 in your packet on logarithms. Okay, what is a logarithm? A logarithm, or we just call it log, is another way of writing exponents. So as you see, we have the log form right here, and this is the exponential form. These are both equivalent. If we have log base b of a equals x, that's how we would say that. Now, how is it that we end up going from logarithmic form to exponential form? Is basically where the trick that I use is I just kind of use this arrow that goes around like this. And so that's what helps me to see this. And so if you see how the arrow runs, then log base b, and then x is passing the x, equals a. And it's the same way with exponential form. You always start with the base. So you start pointing like this. And so then we would write log base b of a equals x. And x is always going to be the exponent. Now, just to make sure that we understand how we would write things out, because usually there's some misconceptions on some of this. And if we were to, this is what I would typically see students that would write this. They would write it this way: b to the a power equals x. All right, that's a big no-no. We do not write it that way, okay? It's as if you've got this line here on your paper, and when you write this, you would be writing it in such a way where you have log, and you put the b just real small, and then of a equals x. So that's how you would write that. All right, now common logarithms. A logarithm with base 10 is called a common logarithm and can be written without a base. And so if I have right here log base 10 of x, the same way that I would write this is just log x. Sorry if it's really sloppy. That's how you would be able to get this on the calculator. So that's the reason why that we have log base 10 of x is the same as log x. So here we're converting between the forms, between logarithmic form and exponential form. And so in this case, we have to write each equation in exponential form. And just remember that trick that I was telling you, that you would write it this way. And so if we were to write this out, it would be, oh, it's in exponential form. Seven to the second power equals 49. This one would be 2 to the fifth power equals 32. And if you were to look at this, 7 to the second power equals 49 makes sense. However, if we were to write 49 to the second power equals 7, that does not make sense. So we don't write it this way. So when you look at it and you write it from logarithmic form to exponential form, look at it and make sure that it makes sense. So we have this one. If we were to rewrite this again, remember, if you have just log, it's the same thing as log base 10 of 1,000 equals 3. And if I was to use, I call it the loop-de-loo. If I was to write it like this, then it would be 10 to the third power equals 1,000. This one is 4 to the negative 3 power equals 1 over 64. Now, one thing to remember, the rules on exponents, is that anytime you have a negative exponent, it doesn't mean that the number is negative. It means that you're taking the inverse. So if we were to take 4 to the negative 3 power, and we put this over 1, and we take the inverse of that, it becomes 1 over 4 cubed, and in turn, that equals 1 over 64. Here, this becomes 8 to the 1/3 power equals 2. And in reality, the 1/3 power is the same thing as writing the cubic root of 8, and which in turn does equal to 2. On this one, 9 to the power of 3 over 2 equals 27. And so if I was to rewrite this in radical form, 2 is the index, so then it would end up being the square root of 9 to the 3rd power. And if I was to rewrite this again, that's the same thing as saying square root of 9 times square root of 9 times square root of 9, which is 3 times 3 times 3, which equals 27. Now we're going to be going from exponential to logarithmic form. Again, you point at the base. There's my loop-de-loop. And so then if I was to rewrite this, this would be log base 5 of 25 equals 2. And it always equals the exponent. Here we would have log base 8 of 1 equals 0. And this is an exponential rule, as I'm kind of reviewing on this. Anytime you have log base any number, I'm just going to call it b of 1, it's always going to equal 0, because any number to the 0 power actually equals 1. Okay, here we go. So we have log base 3 of 1 over 81 equals -4. So 12 to the 1/2 power equals 2 square root 3. This would be log base 12 of 2 square root 3 equals 1/2. And just so that you guys, this is a review, so if I have 12 to the 1/2 power, that's the same thing as square root 12. And if I was to simplify this radical, I know that what perfect square numbers go into 12, well, it's going to be 4 times 3. And if I've got square root 12 and I do the square root here, square root of 4 is 2, and that's where we'll get to square root 3. Okay, you can check yourself on this one. You can pause it and check it, but this is how you would convert this one. Now we're going to be evaluating the following logarithms using the knowledge of exponents. So in other words, if I've got log base 6 of 36, if I set this equal to x, and I was to write this in exponential form, 6 to the x power equals 36, well, we know that 6 squared equals 36, so x equals 2. On this one, if we set it equal to x, then this would be 2 to the x power equals 128. And if we were to go ahead and end up dividing 128 by 2, do it this way. So if you were to look at this and just continue to divide it, see there's 1, 2, 3, 4, 5, 6, 7. So in this case, then 2 to the 7th power equals 128. So x equals 7 on this one. So if I was to evaluate this one, this is the same thing as saying log base 10 of 1 over 100. So then if we have it equal to x, then 10 to the x power equals 1 over 100. I already know that 10 to the second power equals 100. And remember, you want it to be the inverse. So then we would say that 10 to the negative 2 power equals 1 over 100. So in this case, you're going to have that x equals negative 2. So on number 16, if we set this equal to x, then we have 16 to the x power equals 2. If I work to try to get the same base on this, I know that off to the side here, I know that 2 to the 4th power equals 16. So if I go ahead and substitute 2 to the 4th power in place of 16, then I would write it this way. And so then if I've got 2, its exponent is always going to be 1. So anytime that I have 2 to the 4x, I'm using the exponential rule. Anytime I have the same bases, now since I have base 2 here and here, then I can go ahead and pull down the exponents. That's the only time that you can do this, and so x equals 1/4. So here, if I put equals x, so 3 to the x power equals 1 over 27. And I know that 27, 3 to the 3rd power equals 27. And if I go the other way around, use the inverse, then I know that 1 over 3 to the 3rd power is the same as 3 to the negative 3 power. So in this case, then x is going to equal negative 3. On this one, so 8 to the x power equals 1. Well, the x is going to equal 0 by that exponential rule. All right, so now we have the change of base formula. The whole reason why we use the change of base is so that we can put it into the calculator. We don't have, well, in some calculators you can actually put it in where you have log base b of a in this form. There's a way to do it, and I believe it's in the catalog if you look for it. But what I'm wanting you to see is that if I've got log base b of a, then it's equivalent as writing it log a divided by log b. So we're going to use that. So if you look on this one, I have it shown on the calculator where we have log base 5 of 34. And so in reality, what we're doing when we put it into the calculator is that we have log 34 divided by log 5. And once we do that, then our answer is going to be 2.191. Same thing with this one. So if we have log base 2 of 98, we want to be able to write this out in the calculator. So we would say log 98 over log 2, And when we do that and put it into the calculator, it's 6.615. Okay. So I'm wanting you guys to try it, pause it, and see how it goes and see if you end up with the answers, because all I'm going to do is just erase these and show it to you. So log base 20 of 4 is going to be 0.4628. Log base 6 of 2 is approximately 0.3869. Log base 3 of 225 is 4.9299. Log base 8 of 1/2 actually equals negative 1/3. The next section that we're going to be going over is what we call natural logs. This is on the bottom of page 19. So if you've got a logarithm that has a base e, it is called a natural log. And if you look on the calculator, it actually has that the natural log button on there. And so whenever we have log base e of x, that's just the same thing as natural log x. And so if we were to go ahead and to write this out, it says write each equation in exponential form. So if I was to go ahead and use the rule here, let me move it up so that I can write. It's kind of hard to write. So this would be the same thing as saying log base e of x equals 4. So we would say that x equals e to the 4th. That's if I was to go ahead and use the little loop-de-loo right here. Okay. On this one, it's going to be e to the x equals 10. So this one, now we've got to write each equation in logarithmic form. So if I was to write it this way, where I'd say log base e of x equals 50, okay, well, log base e of x is just saying natural log x equals 50. This one's natural log of x equals 0.5. The answer is always going to be the exponent. I wrote this incorrect, so let me make a correction. I bet you some of you guys found that. So my apologies. It should be log base e of 50 equals x, which log base e of 50 is the same thing as saying natural log 50 equals x. Sorry about that. I'm glad I caught it though. All right, so if you were to go ahead and put this into the calculator, natural log 64 is 4.1589. And so on the one on 30, if we were to put that into the calculator, then it's going to be approximately negative 1.0986. That concludes the definition of logarithms. The assignment is on page 20 if you would like to go over that. I am going to go ahead and post only the answers in Google Classroom. I'll probably have to put it into a PDF. You can check your answers on all the previous assignments. And then whenever we meet in Google Meet, then I could go over some of that if you guys have any questions on anything. All right? So good luck, and we'll see you later.